Well, welcome to section 4 on measuring angles. Our objective today is to find and compare the measures of different angles, and we will be discussing the definition of an angle as well as identifying how to label angles. So our key concept is the angle today. Angles are formed by two rays, and these two rays share an endpoint. You can see in the diagram here we have a picture of an angle formed by ray AB and ray AC, and the endpoint, or excuse me, the vertex, which is the point where the two rays share the endpoint, is point A. That's called the vertex. Sides are called, the rays are the sides of the angles. The interior of the angle are all the points inside of angle BAC or CAB. You can name the angle in a variety of ways. This could be called angle 1, angle BAC, angle CAB, or just angle A. However, the single letter is not okay if it's arbitrary, if there's another angle next to it. Usually we will label angles with 3 letters unless it's very obvious that it's only one angle. When you're naming the angles using the 3 points, the vertex is always the letter in the middle, so you'll notice that in the two references above, that letter A, which was the vertex, was the vertex that's in between those two rays, and that's always the one that goes in the middle. The interior contains all of the points in between the two rays. The exterior contains all the points outside of the two rays. So here's some practice at naming angles. What are 2 other names for angle 1? Think about that for a minute. Pause the video if you need to. All right, so here are 2 other names for angle 1. We could call it angle JMK or angle KMJ, and that is the name for angle 1. What are 2 names for angle KML? KML right here. Well, we could call it angle 2 or we could call it angle LMK. Would it be correct to name any angle, would it be correct to name any of the angles angle M? Well, if we just said angle M, we're not sure whether we're talking about angle JML or angle 1 or angle 2. There's 3 different angles there. So this is an example of when you would definitely need to use the 3 letters to name your angle. One way to measure the size of an angle is in degrees, and the way that we indicate that it's the measure of an angle is this italicized lowercase m. So you'll see it like this. The measure of angle A is 62 degrees, and that's all we're going to work with, our degrees. So our protractor postulate says that if we have 2 rays, OB and OA, and every ray of the form OA can be paired 1 to 1 with a real number from 0 to 180. Basically what that's saying is every angle has a measure between 0 and 180. So that protractor postulate allows us to find the measures of angles. And the way that we're going to do that, if our rays are not on the 0 line here of our protractor, all we're going to do is find those 2 numbers on the protractor and subtract them and take the absolute value. So that's what the measure of angle COD would be, just subtracting those 2 numbers. We can also classify angles according to their measures. If an angle has a measure between 0 and 90, bigger than 0 but less than 90, we call it an acute angle. If it's equal to 90, it's a right angle. If it's more than 90 but less than 180, it's an obtuse angle. And if it's equal to 180, we call that a straight angle. So those are 4 names of angles that you definitely need to know how to identify. This symbol right here, I think you're familiar with this. This little box down here indicates a right angle. So if that is indicated in a diagram, you can assume that it's a 90-degree angle or a right angle. Measuring and classifying angles. What are the measures of these 3 angles? Classify them as acute, right, or obtuse. Well, to begin with, where is the 0 mark for a given angle? Well, the 0 mark is aligned with one of the rays in an angle. Okay, you can see it on a protractor. So, and you can always rotate your protractor to be at a 0 mark. So let's start off with angle LKN. Well, angle LKN right here. Now that looks like it's an obtuse angle, right? It's bigger than 90. And its measure, if you're able to see that close enough, is 145 minus 0, or 145 degrees. Let's go ahead and look at the next one, which is angle JKL. And angle JKL, this one in green, JKL, that looks like an acute angle. It's less than 90. And its measure is 90 minus 145, which gives us negative 55, but we take the absolute value, so we have a 55-degree angle. So that was between 0 and 90. And lastly, we want angle JKN. And JKN looks like a right angle, so its measure is 90 degrees. Angles with the same measure are called congruent angles. So that means that their measures are equal. Here's the sign for congruent. It's an equal sign with a little squiggly above it, and that means congruent. Congruent means absolutely the same measure. You can mark angles with arcs to show that they're congruent, and you'll see that right here in this example. This little red mark right there, those little arcs, indicate that those two angles are equal or congruent. Here's an example. It says synchronized swimmers form angles with their bodies as shown in the photo. If the measure of angle GHJ is 90, so GHJ, this angle right here, what is the measure of angle KLM? And KLM is just on the opposite side of her arm. Well, since those are congruent according to the diagram, you see they both have two little arcs, then we can assume that those are equal in measure, so it must be 90 degrees. Here's an angle addition postulate. If we have a point B that's in the interior of an angle AOC, then the measure of angle AOB plus the measure of angle BOC must add to the total angle AOC. Kind of logical there, easy to figure out. So let's do an example. Here we have angle RQT, and they're telling us that's equal to 155 degrees. So what is the measure of angle RQS and the measure of angle TQS? We want to know what is the measure of these two smaller angles. Well, what we're going to do is we're going to take the algebraic expressions in the interior there, add those two together, and set those equal to the total of 155. So we have 4x minus 20 for RQS and 3x plus 14 for TQS. Add those together and they equal 155 because they told us that in the beginning. Well, now we can add our like terms. We have a 4x and a 3x giving us 7x. A negative 20 plus 14 is negative 6. That's equal to 155. And if you remember from your algebra skills, we have to add 6 to both sides. So we have 7x equals 161, and then dividing both sides by 7 to get x by itself, we get x is equal to 23. Now we're not done once we find x. Remember, we're looking for the measure of those angles. We found what x was equal to, so now we need to substitute that back into each of these expressions for the angles. So that means RQS is 4 times 23 minus 20, which gives us 72 degrees. Angle TQS is 3 times 23 plus 14, giving us a total of 83 degrees. And if you add those two together, 83 and 72, you do get 155, so it works. On the next page, you have a quiz. Please make sure you put your name on the top of the quiz somewhere. You will be handing that in class tomorrow when you come in. So just somewhere up here, put your name on the top, and then that page you will actually turn in for credit. Good luck. See you tomorrow.